Okay? It's right up here. It's on your formula sheet. But if I have 5, 3 like this, which is the same as 5, choose 3, it is one of those formulas that I'd like you to know, in that you're always going to have the first number on the top of your fraction. You're always going to have the second number on the bottom of the fraction, along with whatever number is left that would add up to the top. 3 plus 2 is 5. And then when you're going to simplify this, you would start by expanding whichever one is the biggest one. 5 factorial means 5 times 4 times 3 times 2 times 1. So when I'm expanding this, I'd say, well, that's 5 times 4, and it's times 3 times 2 times 1, but I can just stop at 3 and say 3 factorial, because I have one of those on the bottom, so those would simplify. Then I have 20 on the top. 2 factorial is just 2. 20 divided by 2 is 10. These are all non-calculator questions. Do the next 4. Perfect.
Except for the D, I kind of forgot that.
Now, this formula is on your formula sheet as well. When everything so far that we've done in this unit in your formula booklet has been under the probability and statistics section. But this stuff that is stuff from the previous year, even though it's similar, it all comes out of your algebra section. And at the end of your algebra section, there's a binomial coefficient and the binomial theorem. And this is the binomial theorem formula for the IB course. This same formula was on your grade 12 pre-calculus formula sheet last year in a different way. Last year, you had the formula, and it looked like this. So let's compare these formulas and see how it works. First of all, now we're not using n choose k anymore. We're now using this format for writing it. So if this formula was written that way, we'd have n and k like that in brackets. Notice a slight difference. They're using n and r. Okay? The a and the b are the same, but instead of n minus k and b to the k, I mean, yeah, that's exactly the same. This formula that we had in grade 12 shows up at this part of their expansion. But instead of telling you that that's tk plus 1, they start right from the beginning and develop a pattern. Term 1 looks like this. It's a to the n always. Term 2 looks like this. N choose 1. And then they go dot, dot, dot. So they're hoping that when you look at that term 2, you recognize some patterns. You recognize that the number that goes in the bottom here, the n choose k, is always one less. It's always one less than your term number. Does that make sense? So we noticed that last year, but that shows up in this expansion by having our second term and having one less there. So we know that this one here is term r plus 1 because there's an r there, and we know that that's one less than whatever term that we're finding. And this will be our last term, b to the n. So it's the same formula, just written in a different way. So if you were trying to find term 7, well, it would be 9 choose 6. Your a is 2 to the x to the 9 minus 6. Your b is negative 3 to y to the 6. And you would go with your calculator just like you've done before. So we go 9 choose 6. Find out that that's 84. 2 to the power 3 is 8, x cubed. 3 to the power 6, 729, and it will be positive y to the 6. And then you can just put your coefficients together. So 84 times 8 times 729 x cubed y to the 6. That's an exact number, so you don't need the approximation signs there. You can use an equal sign because we just found the 7th term. So one type of questions that we did last year was finding a specific term. I think we have time for one more. Oh, I should, yeah, maybe we'll stop there.